Look, let us take the example. Let us take the example of a very hot object. It could be a ball and another hot object, another ball. Not a hot object, a cool. So we've got one hot ball, metallic ball. We've got a ball at room temperature. At room temperature. We have got another ball here, and there is a rod here. So there is a rod here. Then we have got this inside a room. We got this everywhere. This is inside a room. Now, the a good student of physics or chemistry or science will start visualizing things. You see, what is science? What a normal layman doesn't see, a scientific person who's gone through books sees because he's read something which others have worked on. So the first thing is that whenever you give an answer, you try to see what's happening in the room. So the first thing will come into your mind is this hot body must be at a higher temperature. So the room temperature is, let's say, 27 degree. The hot body must be at what temperature? Well, you can go very high. You can go to more than 100 because this is not water. It won't boil. This is a metal object. Go 10,000, whatever. But I will take a reasonable temperature of, let's say, uh, 120 degrees, quite hot. Now, what's in the what matter is around? What a layman doesn't see, what a person who has read science sees. He knows there are particles in the air which are moving around. And what here inside? They are particles of the metal ball which are vibrating. They are vibrating. So this he sees. Any other thing he sees is when I say it's a metal ball, and let's say here this is this there's another let's say there's another ball, and I've got another rod here, and let's say this is a plastic uh, rod, though this is a metal ball, and this here, this is a, let's say a metal rod, and this is the same metal ball. Okay, every metal balls are same, but they are at different temperatures. So we got these things happening here. So what will be happening? The This metal ball has got electrons moving zigzag, going around at fast speeds inside. The vibrating. What about this metal ball? They are particles, but they're not vibrating so much. You have electrons, but they're not moving around so fast. Here also the same thing. They are vibrating less, and the electrons are moving about less. This, if you could see by some eyes of God, you could see that the particles are vibrating very strongly, and the electrons are going zigzag, zigzag, zigzag very fast. Okay. So what happens now? Whenever a particle is electrons, you will learn in higher classes, electrons when they move, we call them accelerated charges. Accelerated charges. And accelerated charges have an ability to generate electromagnetic waves. Only accelerated charges can do that. And light and infrared are types of two types of, so these they start generating EM waves, and in the infrared waves transfer energy because they're termed as electromagnetic. They have an electric field and they have a magnetic field. So they are, these magnet has an energy and electric field has an energy, and that energy is getting transferred. So this energy is coming, and this energy is also coming here, and it hits the ball. And what happens? This and the electrons, and they start vibrating more. The electrons and they start vibrating more. And what will happen is Because initially they were 27 degree was the room temperature. This was also 27 degree, because there is a rule in thermal physics that if the temperature is same, then the net heat transfer is zero. Now that doesn't mean there's no heat transfer. There will always be some heat coming here from the air molecules and some going away, but the net will be zero. That means there's no net. It will be because both of them are equal. So they if it is here, there will be more. Won't be net, because more from this side and less from this side. So what is happening is this, there's a net heat transfer, and the vibrations of this will increase, the electrons will increase, and gradually this will become heat hot. Now this is, I'm all only talking of radiation, but heat transfer takes place through three mechanisms: radiation, conduction, and convection. So why not conduction? Because it's not touching it. It's not touching it. But is there any conduction happening? Yes, there is air particles touching it. There is a segment of air in between. So why don't we say that air will conduct? Air is a poor conductor. So the first thing you will say, though if the teacher doesn't ask you all this, don't give. It's chiefly radiation by which the other metal ball, which is far away, is getting heated up. So, but what about the conduction? The conduction, the particles are there, but there's so much gap between them. They can't touch, even the air particles don't touch each other, so they can't conduct, because air has got a lot of space in between air particles. So that is why the air is a poor conductor. Though there is presence of matter there, there is a presence of matter between the two balls, that is air. But air is is a poor conductor, is a considered an insulator, because the air particles are so, there's so much gaps in between them, they can't conduct, they can't don't touch each other. And also what is air? Air is, you visualize all this, air is CO2, it is chiefly nitrogen, it is 20% oxygen. All these are covalent. All these are covalent in chemistry. If you have learned, all these are covalent. And and there are no electrons, no free electrons. So something is totally absent. And that is what is happening in the plastic rod. The plastic rod is a polymer. If you will gradually learn in chemistry, it's an organic compound. Organic compounds, polymers, are made up of again covalent bonding, and there are no electrons. So the plastic is a poor conductor. So even though this rod is conducting, but it is also a poor conductor, but it will conduct. The the molecules will vibrate. The molecules will vibrate. So it doesn't mean that it won't conduct. So, but plastic is a poor conductor. It will, the electrons are absent, so only the molecules are vibrating, and the molecules, there's one thing absent, so conduction is poor, but better than air. Better than air, there's no contact. Then what about, we talked of radiation, we have ruled out conduction. What about convection? Well, convection does happen, but there's a problem. Convection is basically air particles uh, do convection. Why? Because the air can expand, it's a gas. So why air, if air can't conduct, but it can do a lot of convection. But why convection? What's so special about air that it will convect? Because it is a gas. Gases expand more. That's how engines in cars work. Gases expand. Gases have this ability to expand. So when gases can expand, the density changes will happen and convection will happen. But convection goes up. Convection goes up. It doesn't go towards the side. So this is, I asked you, when you stand in the kitchen, how do you feel the heat? You feel the heat if you're standing away from the burner, you feel it through radiation. But if you put your hand over the flame, then you will feel it through convection. So don't say, in the kitchen, if somebody is working near the flame, if she's really over the flame, then she will get heat transfer from convection. But if she's standing away from the flame, it will be it will be radiation, but it won't be conduction. So these are the three things. Don't don't say it will be only radiation. It will also be convection, but provided you're right on top of the flame, then you feel the heat. That's how the utensil gets the flame. Utensil is getting the flame from two ways. One, then I asked you what happens in the candle thing. So let me um, Acha, what happens is, of course, again the radiation also heats up the air molecules, but again the air molecules are um, less in density. So it's basically the walls it will hit, and then, but it also warms up, and then the walls start re-radiating back, and then the air keeps on getting heated around it. So this is the basic concept. Gradually, what will happen is the hot ball will, because this is 120-degree, it's emitting energy, it's losing energy. Now, what is temperature? Temperature is average kinetic energy of each particle. So as it's losing energy, as the kinetic energy, because it's emitting EM waves, it's generating EM waves, so it's getting this energies of these particles is getting converted into another form, into a EM wave. So the energy of this will fall down, and as it falls down, the temperature will start falling down, and at the same time, this is getting more kinetic energy. So the particles are vibrating more, and so this temperature will start rising, and this will start falling. So through radiation, what is happening is the average kinetic energy of one body is falling, the other body is rising, and the temperature will, one of the bodies will fall, the other will rise, and gradually they will become nearly equal. But that will take time, because this is going to take a lot of time through radiation. And as also the heat loss will will I mean, it's not time, but there will be a lot of heat losses, and everything will get hot. This will fall down, and gradually, if the heat escapes outside, I mean, whatever, if this is a closed container, everything is closed, then it will rise, everything will rise, but this will fall down. And if it's really closed, I mean, there's no escape of heat, but that is rare, it's very possible. So this is what happens. Okay, next.